All right. So in this case, I want us to consider our equations, which is working with our algebraic equations. That is the introduction part that you need to understand the basic concept of your equations. How are you going to solve these typical equations? So I want us to understand this basic part that we had before. Remember when you were having this part of the inverse, when you are talking of the additive inverse and the multiplicative inverse. We've got two things to consider there. That is the additive inverse. So we are going to consider this. That is the additive inverse, which is the inverse property of what? Of addition. So they were simply talking of the inverse property of addition. I want you to consider something what you had there. Remember, we're saying if you're given x plus a minus x like this, which means a number, when added to a negative of that same number, it must give us what? A zero. The same concept, if maybe, let's say we are given a number which is 5, you add, so to give or to obtain a zero, you must add a negative. You must put a negative on this number. So that is a minus 5 like this. So this is going to give us what? A zero. That is the additive inverse. This is what you had before. You also had the multiplicative inverse. Remember that. I want you to just have this basic. Remember this part also, the multiplicative inverse, where you were considering the multiplication of a number and its inverse, which is the reciprocal of this number, which is 1 over x. Remember, a number times its inverse or its reciprocal is supposed to give us a 1. So let's say we've got a number which is 2. We multiply it to its inverse, the inverse of 2 or the reciprocal of 2, that is 1 over the number, which is 1 over 2. This must give us a 1. Remember, guys, 2 over 1 times 1 over 2. This can simply cancel, then you remain with a 1. Or you can just multiply direct. That is going to give us a 1. So these two things that we have, they are going to help us in the solving of equations. So what is it that you're considering to an equation? What is it that we are talking about here? Remember, we had an expression, 2x plus 1. That's an expression. You are given 3x minus 3y plus 2x. It's an expression that you need to simplify. An expression you simplify. If you are given expressions, you are going to simplify them. So what is the difference that we have now to something that we now call an equation? For us to consider an equation, we must have a statement which is from an expression 2x plus 1. That's an expression. So we must have this statement or this expression now equated to a certain number or to a certain expression or term, whatever that you're given. Maybe it is equal to 0 like that. The moment we write 2x plus 1 is equal to a 0 like this, the moment we have a certain expression or a certain term that you're going to have depending with what you're given on the left-hand side equal to another part which is on the right-hand side. That is what you refer to as an equation. So it separates two things, one on the left, another one on the right with an equal sign. They are separated with an equal sign. You call that one an equation. So it is different from an expression. An expression is just 2x plus 1, or maybe you're given 2x plus 1 plus 3x. Simplify. There is no equal to there. You just simplify, you collect your like terms. So the way that you are simplifying these expressions, somehow you are going to have it in the solving of equations. So like I said, expressions, you were simplifying these expressions. But as for an equation, what are we going to do? We are going to solve. In this case, you must solve for the unknown. What is the unknown? The unknown, that is the x, the part of any letter that you're given. Like in this case, the variable that is there, the letter that is on an equation, we must find the value that is supposed to be representing that x. So you're solving for the unknown. Is it for x? Is it for y? Whatever that you're given. So equations, we solve. Expressions, we simplify. So using the part of the additive now, I want us to consider this part that I was talking about before. Part of the additive and the multiplicative inverse. All right, I want to talk about the additive inverse first. Remember, you're saying if you add a number to its negative value, we must obtain a 0. Using that condition, let's say we are given a simple equation. I want us to see something here. Solve for x, or solve the equation. So like I said, equations you solve. We want to have a simple equation. X plus a 2 is equal to 5. Okay, this is it. You need to solve for x. This is the unknown value that you are given, or that we have in our equation. All right. So this is the one that we want to find. You need to find the value of x. You need to find x. To solve for x is to find, you must find the value of x. That is to solve. You must have what is x representing. Okay, let us just take it back to a mental state that we can do it by just looking into this equation. Think of a number that you can substitute, that you can put here. Think of a number that you can put here. You add that number to 2 and you obtain a 5. Just think a number that you put here. You add that number to 2, you obtain a 5. Which number is that? That is a 3. 3 plus 2 is equal to what? To 5. 3 plus 2 is equal to 5. A number that is here, that you put here, you add that, it gives us. So the number, we can even, by just looking into the equation, x minus 1 is equal to 3. Which number that you put here, you subtract 1, you obtain a 3. Which number that you can put? That's a 4. 4 minus 1, that's a 3. So we can see some of these. We can even solve them by looking into the question. We can just, okay, that's the number there, which is 3. But now, that's not the concept. We need to apply some concepts in solving, which is, you might be given like these questions here. Solve the equations below by using additive and multiplicative. There is a certain part that you need to follow. So that is now what we have to consider. All right. So I say that when you are using the additive, because there we just need to remove these 2. So the concept there is, how can you remove these 2 so that you remain with x? So we need to get rid of what? We need to get rid of 2. So we must remove 2 from the left-hand side. So I'm just going to write in short the left-hand side like this, left-hand side, but I'm saying this side, the left-hand side. All right. So how are we going to remove these 2 from the left-hand side? The 2 is added there. So you just go back to the concept. 2, to obtain a 0 there, what are we supposed to do? We are supposed to work with the additive of these 2, which is add a minus 2 to a 2. If you add a minus 2 to a 2, what are you going to obtain? You obtain a 0. Remember your additive concept. X plus minus x is supposed to give us a 0. As long these 2 are the same, but only that another one is having a negative, you must get a 0. So meaning to say, this is what you're going to do. You are going to add a minus 2, meaning to say you're simply subtracting a minus 2 as a 2 from this equation. So it is going to be like this, x plus 2. Then we want to remove this 2. So to remove it, we are going to what? To subtract a 2. 2 minus 2, that's a 0. Meaning to say we've got what? A 0 there. But this is an equation An equation, take it as a scale, a balance scale. If you take those balance scale, if you put a scale to balance, you must have two things that are of equal mass or whatever that you have for these two balance. If here we've got 5 kilograms, we must also have 5 kilograms. So what is going to happen if you remove 2 kilograms here, you subtract or you add 2 kilograms, whatever that you do, you remove 2 kilograms here. You're also supposed to remove 2 kilograms this side so that it balances. It's just like a balance scale. What is on the left hand side must be equal to what is on the right hand side. So this is left hand side. And there we've got the right hand side. Remember your left and right hand. Okay, that is the same concept. This is your left side. This is your right side. So we are saying it's like a balance, that scale where you put something here. If you add something this side, you must also add also that side for it to balance. It must balance just like a scale. That is how an equation operates. So it must balance. So whatever that you do on the left-hand side, you must do it on the right-hand side for it to balance. Whatever that you do on the left-hand side, do it also on the right-hand side. So this is equal. So what separates the sides is the equal sign. So when I'm saying the left-hand side, this is the side, this one. The moment we put an equal to, we are now talking of what is on the right-hand side. So on the right-hand side, remember, there was already a 5 there. 5 was already on the right-hand side. So what is it that we did on the left-hand side? We subtracted a 2 so that we obtain a 0 there. So we are going to do the same thing. We subtract that 2 on this side. Whatever that you do on the left-hand side must also be done on the right-hand side. So that is it. So as you can see, guys, 2 minus 2, that's a 0. So meaning to say you are just left with x, because x plus a 0 is what? It's x. So that is an x that you're going to have, which is equal to what? 5 minus 2, that's a 3. So look, you're obtaining the same answer that we obtained before by just looking into the equation. We say, okay, this is the number that we can put there is a 3. So meaning to say our x is supposed to be 3. So we can even check this to see if this is true. You are supposed to check to prove, to check that is to prove. That is, is it true? So where x is, you're going to substitute the 3. So in place of x, that is 3 plus a 2. Remember, that's plus a 2 there. Is it going to give us a 5? 3 plus 2, that's a 5. So 5 is equal to 5. Truly, we can see that these two are the same. So this means this value of x is true. If you substitute the value of x where x is and you obtain a certain value which is not a 5, that means that is wrong. You have to consider solving your equation again. All right, so as we saw that, if you are given a part where x is, you can simply subtract or add whatever that you're given. So let's consider to say it was a minus 2 this time, which is equal to 3. X minus 2 is equal to 3. So using the additive concept, we saw that for us to obtain a 0, you're supposed to add a minus, like what we have x plus. So meaning to say from this concept alone, it is simply telling us that if one of the numbers is a positive, one is supposed to be another one is supposed to be a negative, the same number. If this is 2, the other number is supposed to be also a 2, but just carrying a negative so that we obtain a 0. So it means we can even start with these 2. It can be like this, minus 2 plus a 2. As long one is negative, another one is a positive. As long one is negative, another one is a positive. You must obtain what? You must obtain a 0. So the order is not important. Are you starting with a minus? The other one, let it be a positive. Are you starting with a plus? The other one, let it be a negative. So this is it. The number that we want to remove here is this one, so that we remain with x. Remember, what you need to do there is to solve for x. The x is the one that you need, this one. So you need to get rid, to remove this time minus 2. You must remove this. So how can we remove this? It's a minus. So what are we supposed to do? We are supposed to add this time. So it is supposed to be like this, x minus 2. This time, for us to obtain a 0, it must be a plus. Like I said, one must be negative, another one a plus. Negative, or a plus, another one a negative. So since we have a negative, it means whatever that we must add must be a plus, so that we obtain what? We obtain a 0. Whatever that you've just added on the left-hand side must also be added to the right-hand side. Where there is a 3, we must also do the same thing. That's an equation. You add also a 2 there, just like that. So by doing this, as we can see, this whole part here is going to give us what? A 0. That is the minus 2 plus 2. It's a what? It's a 0. So x plus a 0, that's what? That's x. So meaning to say, you are obtaining x there, which is equal to, you can add on the right-hand side, 3 plus 2, that is a 5. Just like that. So this is the x value, which is going to make this equation balance. For this equation to balance, x must be a 5. So let's try to check out, is this going to balance? Because like I said, it must balance. So that is where you have to check. Where x is 5, where x is, we are going to substitute a 5 in place of x. So that is 5 minus a 2. Is it equal to 3? All right, 5 minus 2, that's a 3. Exactly equal to the 3 that we have on the right-hand side. So as we can see, this is equal. So this value is correct. So the value there is correct. All right. So it's true, very, very true. We are trying by all means to apply some laws that we have, like additive. You have to add that number, this and that. But I want you to check properly here, or I want you to consider that it's simply a straight thing that we can solve even without the concept of adding this, or this is how you can just solve it direct without using this concept. Okay, how can we solve this? This question is, you need to solve for x, remember? So this is just another way where we can just solve without like adding this or subtracting this. What you just need to get rid is that if a number is being subtracted like this or being added like this, if a number is being subtracted or being added to x, that number can be removed from where it is and taken to the other side of the equal sign. But the moment that number jumps the equal sign like this, the moment that we see this number on this side, the moment, because we want to remove this one. So the moment we take it to the other side of the equation, it changes the sign. So the moment it jumps the equal sign, it changes the sign. The sign is supposed to change. So it was a minus. So we're going to see it on the other side. It will be like this. X, it's no longer here. It has jumped. Guys, to jump, if you jump, it means you're no longer at that position. If you were at this point, then you jump to this point, like jump there. You're no longer there. You are now at this point. So it is the same thing. We are no longer having minus 2 here. It has jumped to the other side of the equation. But the moment it jumps, what is going to happen? It changes the sign. It was a minus, so it will be a plus 2. So it must change the sign. Jump the equal sign, change sign. So meaning to say, x is equal to what? 3 plus 2, which is a 5. As you can see, we are obtaining the same value of x using this concept. A number can simply jump and change the sign. So I want us to consider another one using this concept so that you can understand what I'm trying to say. it can be like this. X plus 5 is equal to 7. So whenever you're given this, you need to remove this 5. So what are you going to do? Jump this to the other side of the equation. The moment it jumps, it changes the sign. It was a plus. So what is going to happen? It is going to change to be a minus. This part has jumped to the other side. So it will change to be a minus there. So we are going to see this now as a minus. Already there was a 7. So you start with a 7, which is already on the right-hand side. Then the 5 changed as a sign. So it's no longer plus. It's now a minus. It is now a minus. So meaning to say x is equal to 7 minus 5, which is a 2. Just like that. So you can even check if x is a 2 there, 2 plus a 5 is equal to a 7. 7 is equal to 7, which is true. So that is, we can solve these equations using this concept. Just to remove a number, it must be taken to the other side of the equation. From x, this number is being added or subtracted. It is different from a condition where it is like 2x is equal to 1. This one is not added. It is multiplying x. So the way that you remove this one is different. So that is how we want to check. How do we remove such type of, how do we solve such type of equations? So that was it, guys. Let us consider now the part of the multiplicative inverse, this one. Remember, on the multiplicative inverse, we are simply saying, if you multiply a number and its reciprocal, 1 over x is the reciprocal of this. 2, 1 over 2, the reciprocal, the inverse. So if you're just given 3, the reciprocal of 2 of 3, it is simply going to be 1 over 3. 1 over 3. That is the reciprocal. So the question is, if this can happen that you multiply and you get a 1, 2 times 1 over 2, you get a 1. How can we solve equations using this concept? All right, let's say we are given something like this, solve for x, or just solve an equation. Then you are given something like this, 3x is equal to 2. 3x is equal to 2. This is different from the previous question where we are given 3 plus x is equal to 2, or x plus 3 is, this is different. 3x means 3 times x, 3x, 3 times x, not plus. So in this case, we cannot subtract a 3, we cannot add a 3, we cannot cross this, we cannot jump it to the other side because it is multiplied. There's a multiplication that is there. So using the multiplicative concept, it is telling us that if you are to, because what you need to solve, guys, is to remain, you need to remain with x. You must find x. This is what you need here. You need this x. So what you simply need to do is to remove the 3 that we are seeing here, this 3. And what is this 3 doing? It is multiplying. So we can say 3 times its inverse, which is the reciprocal, 1 over 3. Remember, it gives us what? A 1. X times 1 over x is equal to 1. So by multiplying by 1 over 3 on a 3, you are going to remain with a 1. Guys, if you remain with the 1, let's say it's 1x. 1x is equal to x, remember. So having 1 on x, it means we are having x already. So that is the case that we want. So we are going to do this, multiply by 1 over 3, so that we obtain a 1. But remember, whatever that you do here must also be done on the other side of the equation. You multiplied by 1 over 3, you must also multiply by 1 over 3. So doing this, you are simply 1 over 3 times a 3. We are back to the multiplicative inverse, which is going to give us what? A 1. So 1 times x, that is going to be 1x is equal to 2 times 1 over 3, which is same as 2 over a 3. X is equal to what? X is equal to 2 over 3. Remember, 1x, it is that x, guys. 1x is this x. So this is the concept that you must have on the multiplicative. You must find the inverse, then you multiply by it. So simply we can see that it is just a situation like this. Solve 2x is equal to, instead of me multiplying by 1 over 2, this is the case. A multiplication divide by the number that is multiplying here. The opposite 2 times x. To remove where the times is, you must divide. Opposite, divide. So we divide both sides by 2. Just divide. Okay, so in this case, divide in short. Okay, divide both sides. Remember, it's an equation. Whatever that you do on the left-hand side must be done also on the right-hand side. So divide both sides by what? By 2 in this case. So meaning to say, if you're given 2x is equal to 4, I can simply divide by 2, just like that. To divide by 2, we are multiplying by that multiplicative inverse, but we are just doing this in a disguised manner, but we are using the same. So that is what gonna be our x. Remember, if you cancel 2 and a 2, you get a 1, and 1 times x, like I said, is x. All right, then you can divide 4, divide by 2, that's a 2. So our x is a 2. We can actually prove this and see if this x is equal to 2. So let's try to check this one. In place of x, we are going to substitute a 2. But remember, 2x means 2 times x. So it means 2 times our x. What is the x value? We obtained our x as what? As 2. So 2 times 2 is equal to what we have on the right-hand side, which is a 4. 2 times 2, that's a 4, which is equal to a 4. Truly, these two, they are equal. 4 is equal to 4. That means our value of x is correct. So that is the concept now that you're going to use. So using these, they can be combined now at the same time, where you need to apply the additive and the multiplicative at the same time. Let's consider this equation that I wrote here in the first place, because someone will be asking, what about this one? How are we going to solve this equation? All right, I had an equation that I wrote in the first place here, 2x plus 1 is equal to 0. So we are going to, as we are seeing this equation, there are two things to be considered in this equation. Remember, you need to solve. There are two things that we need to consider there. 2x plus 1 is equal to 0. 1, there is a number which is added here, which is being added. 2, there is a number that is multiplying x. It is multiplying, it is not adding, it is multiplying x. So meaning to say here we are going to use the additive inverse to remove the 1. To remove this 1. So if you are using the additive concept, you're going to be plus 1. What are we going to do to remove this 1 so that it gives us a 0? Remember, we subtract. If this is a plus, the other one will be a minus. So this is equal to what? 0 minus 1. Remember your concept. Remember your concept. 0 minus 1. So meaning to say, as we are going to subtract 1 minus 1, that's a 0 there. We are no longer having this. We are no longer having this. That's a 0 there. You are left with 2x, because that one gave us a 0, the whole of this part. So this is equal to 0 minus 1, which is a minus 1. All right, there you can just use your calculator. Do not panic. 0 minus 1, it is going to give you a negative 1 like that. So what you need to do is to solve for x. Now, look at the stage that we are. We removed this 1, which is true. But look what is remaining. This is the same equation like what we had before. 2x is equal to 4. How did we solve this? We said a multiplication, you simply divide by the number that is multiplying. That is the multiplicative inverse. We are just doing the multiplicative inverse in disguise. So there is a product, you simply divide by 2, both sides. Whatever that you have there must divide both sides. So x is going to be minus 1 over 2 when given something like this. So those will be your typical exam questions of this nature. All right, so if you go through this, you are going to see that there are a lot of things to consider, like what we are given here. Solve the following equations by the additive and multiplicative inverse, then check your answers. So I want you to work these questions, then you check your answers at the end. All right, just like the first part, x plus 10 is equal to 0. So x plus 10 is equal to a 0. Which concept we're going to use? Additive. There is a number which is being added, so we can just subtract a 10. So meaning to say x plus a 10 minus a 10 is equal to what? 0 minus a 10. So that means this will give us a 0. The whole of this part will give us a 0. So x is equal to 0 minus 10. That's a minus 10. So you can even check this and see if this is going to give us exactly what we need there. If x is minus 10, let's substitute in place of x. Minus 10 plus a 10. Take note, there is a plus there. Plus a 10 is equal to a 0. Minus 10 plus 10, that's a 0, remember? So that 0 is equal to, which is correct. So our x is truly a minus 10. So that is to solve. So you can solve, guys, as many questions as you can. So I want us to solve these typical questions. You can even try number 2. You are given 49x plus a 2 is equal to 100. All right. So start with the additive. There's a plus 2 there. So how do you remove the plus 2? So as you can see, guys, we simply need to subtract a 2 because it's adding. So subtract a 2 this side, subtract a 2 this side, meaning to say we are going to have 49x. Remember, 2 minus 2, that's a 0. Then 100 minus 2, that is going to give us 98. Now, we are at the multiplicative. We are multiplying, so you're going to need the inverse. So you divide by the number that is given, which is 49. Divide by 49, divide by 49 this side. So that means our x was going to be 98, divide by 49, which is a 2. That is the concept. So you can solve as many questions as you can. Then you can even prove, that is to check. Let's check this out. If we check this, in place of x, we are going to substitute a 2. That is 49x. 49x means 49 times. So that is 49 times a 2, which means you can even put in a bracket like this. Our x is 2. So that is 49 times 2 plus a 2. It is supposed to give us a 100. All right. Let's simplify and see. 49 times 2, that is 98, plus a 2 is equal to 100. 98 plus 2, that is 100. 100 is equal to 100. As you can see, the left-hand side is equal to the right-hand side, meaning to say this is true. The value of x that we just obtained is correct. So I want you to try these questions, prove, that is to check if your answers are correct. This one is a straightforward. As you can see, we solved this type of a question before. It's just 2, which is multiplying. So simply divide by 2. So that means x was going to be 1 over 2. Then you can also check that one. All right, what about question number 4, where you are given 20 is equal to 11 minus 9x. So we can even use the same concept. Let's start with the additive, because on this right-hand side, because it's happening on the right-hand side. So whatever side that you are is still the same. So we want to remove the 11 here, which is 11, it's positive 11 that you want. So you're just going to subtract 11. You also subtract 11 on this side. Whatever that you do on the left-hand side must be done on the right-hand side. So you subtracted 11 on the right-hand side. You're going to subtract 11 on the left-hand side. So let's subtract and say 20 minus 11. So that means in this case, we are going to obtain a 9, which is equal to 11 minus 11. That's a 0 there. This one, it is giving us a 0. So you're remaining with minus. Remember, the purpose of subtracting it is to remove this. So it's no longer there. Why are you subtracting? So that you remove that. So it means you are remaining with this minus 9x. So do not be scared when you have got this condition. It's still a product, even though it has a negative. That's a product. Minus 9x means minus 9 times x. Remember, a number can be a negative. So this does not mean that we are adding something there. No, it's still a multiplication. How do you remove that? you divide by the number before x, which is the -9. You also divide whatever that you do on the left-hand side, on the right-hand side here, do it also on the left-hand side. So this was going to cancel. As you can see, they're the same. They cancel. You remain with what? You remain with x. So x there, 9 over -9. This was going to give us a -1. So our x is -1. Remember, if A is equal to B, it also means B is equal to A. So if x is equal to, if -1 is equal to x, like what you can see, it also means x is equal to -1. It's just one and the same thing. If -1 is equal to x, x is equal to -1. So let's try and check if this is going to make some sense. If this x is -1, all right? If this x is -1, that is the left-hand side, there is a 20 there, is equal to 11 minus 9x. 9x minus, it means a product, minus 9x. 9 times x. So you can just put a bracket there. Remember, our x is -1. So 20 is equal to 11 minus times minus, that's a plus. So you remain with the +9 there. 20 is equal to 11 plus 9, which is a 20. So as you can see, these two sides are the same. So that is to mean our x value is correct. So that is to solve equations using the concept there. So some conditions, we might be given a part where we need to collect like terms, the terms of x together, the constants together. It can be like that. Like what we can see on number 5, you're still solving for x. But before you simply subtract all this and that, there are conditions where you can take the terms of x to one side of the equation in order for you to solve that equation. Already this side, x is on its own. So you need to remember the part of algebra, collect like terms. So you must collect the like terms, so the terms of x, but this time you consider the terms of x to one side of the equation, the constants to the other side of the equation. So already in this case, this is the format that we have the part of x, which is our variables in this case, they are already on the same side. Then the constant there is on its own. So there we simply need to add 4x plus 6x. Remember our algebra, these are like terms. So you can add 4 plus a 6, which is 10x, is equal to a 20. Remember your algebra, this can be added like terms. But now that we have got a single term, we are just like what we had here. We're just like having this. 2x is equal to 1. How were you solving that? You're going to divide by the number that is affecting x, which is a 10. So you divide, because the product there, divide by 10 both sides. So x is going to be what? 20 divided by 10, that is a 2. So you can also check if that is true. All right. So that is what you're going to have in this case. If you consider question number 6, the same thing. We are given 5x is equal to 40 plus 3x. So we need to collect like terms, the part of x and the part of x. So already there is 5x. So I can choose to take this 3x to remove this one because there's a constant there. So I must remove this 3x and take it to the other side of the equation. But the moment it does that, remember what I talked about, to take this 3x, for it to jump to the other side, it changes its sign. It was a plus here. So the moment you write it on the other side, it changes the sign to a minus. So it's now minus 3x, which is equal to what? A 40. This is no longer there. It has jumped this side. It's now here, but with a minus. So that's it. So now you have collected the like terms, the part of x, they are on its own. So we can combine them using concept of our addition and subtraction. These are like terms. 5 minus 3, that is going to be 2. So 2x is equal to what? To 40. The multiplicative inverse, you're multiplying there. So simply divide by the number that is multiplying, which is 2. Divide by 2 both sides. So that was going to give us the x value at the end, 40 divided by 2, which is a 20. So I want you to take this value, substitute there, and test your equation if that is true. So this is how you're going to solve all of these questions. So I want you to try them. Question number 7, question number 8, then you write your answers on the comment section so that I can see if you are on the right side. And also, you can actually prove that. You can check your answers if they are correct. So make sure the terms of x are on their own, the constants are on their own, just like what you have on number 8 there. X plus 20 plus 4x is equal to minus 55. So if you are to consider the part of x, there is the x which is already on the left-hand side there, 4x and this x. So already we have got these on the left-hand side. So we can just rewrite as they are, x plus, remember the sign there, it never crossed any equal sign. So it remains as it is. You're just taking the x on its own, just writing on their own, the x and x. So meaning to say that 20 here has nothing to do with these terms of x. So what are we going to do with this 20? Take it to the other side of the equation. But the moment that it crosses, because this, look where the equal sign is. So it has crossed the equal sign. It has jumped. The moment it jumps the equal sign, it changes its sign there. It has jumped the equal sign. It changes the sign. So meaning to say that's minus 55 already on the right-hand side. But the 20 now, he has jumped the equal sign. It will be a minus 20 there. The sign changes from a positive to a minus, meaning to say if it was a minus, it changes to a plus. The sign changes the moment it jumps the equal sign. So let's add. Remember, in our algebraic expressions, we're adding this knowing that there is a 1 there on x. So we are simply adding 1 plus a 4, which is 5x. So this is equal to minus 50 minus 20, which is minus 75. So we can obtain the x value by dividing now. 5x means 5 times x. So it's a product. How do you remove the 5 on a product? You divide by it. The opposite, divide. So x was going to be equivalent to negative 75 divided by 2, which is minus 15 at the end. So that is the x value. And I want you to check this if truly it is going to give us this minus. So you substitute it on the left-hand side and see if you're going to obtain a minus 55. If you obtain a minus 55, then it means our x value there is correct. So that's the advantage of equations. You can test them to see if the x value or if the value that you're calculating there is correct or not. So if you test, then you see that it's not. Just try to recheck. And sometimes also when you check, it's best also use your calculator, because you might try to check using the correct value. Then you check in a wrong manner. Then you think that value of x is wrong. While it's you who just use your calculator wrongly, or it's you who just miscalculated somehow. So make sure that you verify properly. So to avoid those mistakes, do as many questions as you can, revise as many questions as an individual, work with many questions as you can. That can help you to avoid those mistakes, because you are used now to, okay, if I'm working with this question, there's a mistake like this. If I'm working this type of a question, there's a mistake of this nature. So the more you do these questions, that's the more you can simply tell that you are in the right direction or not. So let's revise, as I said, more questions as we can till we meet again.